Okay, go ahead.
Okay. Guys, if you guys are ready, we can start.
Yes, please.
Okay. So my name is Ravi, Ravindra Ramanani. I'm a solution architect with Elastic. We got an opportunity through Augustine to come and present here, so thank you, Augustine.
You're
I'll start with that. By the way, I just wanted to check how many of you guys have heard about Elasticsearch. How many of you have used Elasticsearch?
okay.
Just two. Wow. Good. I'll quickly give a brief about Elasticsearch because that's necessary. Elasticsearch, what it does, and then only we can step onto the machine learning part of Elasticsearch. So I'll quickly run through what is Elasticsearch, what is the Elastic Stack, which contains Elasticsearch, and Elastic as a company. Elastic as a company, we call ourselves a search company.
Yeah, you got it.
So Elastic company actually manages Elasticsearch. Elasticsearch is an open source project. It's one of the most popular open source projects. The entire stack is very popular with developers. It's developer friendly. We have 350 million plus downloads on GitHub. It's a pretty big number. 350 million is a pretty big number. It's completely open source. The core is completely open source. We have certain premium features, machine learning being one of them, but the core is pretty much open source, and it's pretty heavily used across the globe. We have around 1 lakh community members as well who meet regularly across the globe. We have a full-time developer evangelist who is in Bangalore in India, who organizes meetups across India as well. He speaks at conferences as well. So if you guys are active with meetups in Mumbai, we have a decently active meetup community in Mumbai as well. So just go to meetup and search on Elasticsearch. I know very few of you have heard about Elasticsearch, but I can guarantee a lot of you must have used services which are actually powered by Elasticsearch. So I'll quickly run through few of them. I guess most of you must have used Uber. So Uber, when you search a driver on Uber, the matching between the driver and the commuter happens, is powered by Elasticsearch. ETL special queries are powered by Elasticsearch. Yelp, it's an example, but we have similar examples in India as well. They may not be a paid customers, but they use the community version, the open source version of Elasticsearch, be it Flipkart, be it Paytm, be it Paytm Mall, be it Zomato or Swiggy. They use Elasticsearch quite heavily. I'm sure you won't say that you have used it, but you may have used Shadi.
Or maybe abused it.
But you may have used Shadi.com or Jeevansati.com or any of their counterparts. They also use Elasticsearch pretty heavily. Shadi.com has a very good blog on how their tech team has written a very good blog on how they use Elasticsearch internally to power all their searches. Instacart, India example is Grofers and Zomato and Swiggy all are actually internally using Elasticsearch. So even though you guys have not heard of Elasticsearch, but in a way you have used services which use Elasticsearch. Gamers and you, if you use online gaming, if you chat any of the games by Activision Blizzard, quite a few games, we chat with your gamers. All these searches powered by Elasticsearch. The uptime is actually, they monitor the uptime of all their servers via the Elastic Stack. So they use pretty heavily. Indiana University, another example, their complete security analytics platform is built on top of Elastic Stack. So there are a lot of use cases in which you use Elastic Stack. I'll quickly skip the customer slide. Search, I guess you're using search in many ways daily. You search for different things. People use Google. People use Wikipedia. Wikipedia is actually, by the way, powered by Elasticsearch as well. So they use
No, that is
Elasticsearch
different.
internally. Whenever you search any data on Wikipedia, it hits Elasticsearch clusters. All that is powered by Elasticsearch. So different types of data could be free text, could be metrics, could be geospatial. All can be done. All kinds of search can be powered by Elasticsearch. That's why it's the most popular search engine right now in the world, apart from the web search engine that is Google or Bing or DuckDuckGo. We don't handle the web search part, but if you see a search box on a website or an application, there are high chances it's actually powered by Elasticsearch.
So how far is it different from the research?
See, web search, Google or Bing, they index different websites. They have a databases full of website data which have been crawled and indexed into their databases, and then they provide search on top of it. So we just provide a search engine where you can store data. So if you want to create your own Google, you can populate that data in Elasticsearch, and you can provide that services to it.
So basically you're creating a database of yourself.
Yes.
Basically on-premise Google.
Correct.
Yeah.
So, as you said, Google uses on their databases. So, how Elasticsearch uses search data to enhance the users search experience. Like, for example, if I'm searching for Lokmanya Tilak, so by the name of Lokmanya Tilak, there are many roads, there are many colleges, many things are there. So means how you relate and how you increase the user experience based on that keyword.
So
what kind of things you list out in search?
Yeah. So I'll quickly show you the products once. I'll come back to that question in a few minutes. First is different searches that can be powered. What is the differentiation? Scale, speed, relevance. Elasticsearch started off as a search engine, but as the name says, Elastic, it's scalable. It's like scalable like an Elastic. It's horizontally scalable. It's natively distributed. So if you want to increase the number of data sets or increase your data, you just keep on adding servers. You can increase the data that can be searched. So we have customers searching petabytes of data in production. eBay, for example, is heavy user. They have gone on their tech blogs and said that they search on petabytes of data. You have a lot of such case studies available, petabytes of data, getting response in sub-seconds. It's all powered by Elastic. So scale, highly scalable, speed, response in milliseconds, and relevancy, getting highly relevant results, which one you want at what time. So what are the different products in the entire stack? You have Elasticsearch. This was the first product that was actually written by our current CEO, Shai Bannon. It was completely written by him. The first version was built by him back in 2010. Elastic became a company in 2012, and then small other products got added into the stack: Logstash, Kibana, Breeze. So because of the highly scalable nature of the search engine, the core Elasticsearch, people started using Elastic Stack for different use cases, not just for search. Most examples that I gave was for search, but logging became a very common use case where people started using Elasticsearch for. For example, if you have production servers, applications running in production, or any of the environments, they generate application logs. If something goes wrong, you have to go there and search what has gone wrong, go through the audit logs, debug logs, error logs. But you have to log into each server. So another gentleman wrote a product called Logstash, which started shipping those log files into Elasticsearch. So instead of you logging into different servers to search through logs, you had a single interface, a single store for storing all that data and searching through them, running queries on top of it. Similarly, Bates came in for collecting metrics data. Kibana is the visualization layer. Now, Elasticsearch internally, at the core, it's a proper search engine, and it is also kind of used as a NoSQL data store. We don't recommend to use it as a database, but it is a NoSQL data store. Data gets stored in JSON. So when you search, there are search APIs available. When you search a query, search some data, free text data, it returns results which are given a score based on various parameters. Those parameters can be tweaked. There could be filters that can be applied to those parameters. So there are ways to make it more relevant to your use case. So it's pretty powerful. I would recommend go and look at searching by Elasticsearch. There are a lot of blog entries available. There's a detailed guide available. It internally gives you a scoring. It has some scoring algorithm which gives you the best result for a particular string that you have searched on. But you can tweak them as well based on your criteria. So that's an overview of Elastic Stack. Now I've spoken a lot on the search part, but now it has become very popular. The use case that has become very popular is log analytics and operational analytics using the Elastic Stack. What people started doing back in 2012-13, people started shipping their logs into Elasticsearch and then running queries on top of it. Then they started also ingesting their metric data into it. What is your CPU utilization? What is your memory consumption? All that data into it. So if you want to know what is the overall health of your entire production ecosystem, you can ingest all that data into Elasticsearch, run aggregated queries on top of it, create dashboards on top of it, and see the overall health of your entire ecosystem. So that is one of the most popular use cases for which Elasticsearch is also used, apart from search. So that's what we call operational analytics. So if you look at the solutions for which Elastic Stack is used, app search, site search, enterprise search, logging, metrics, APM, it is now also becoming a very good business analytics tool because you have this much data, you have good amount of aggregation available. It's becoming a very popular business analytics tool as well. And one of the newer use cases that people have started using for is security analytics to augment their existing SOC or SIEM tools with they augment it with Elastic Stack because of its scalable nature. You have new data sets coming in. You can do something like threat hunting using the stack as well. So in those kind of scenarios, we thought something like machine learning can help users, and that's how machine learning got introduced a couple of years back in Elastic Stack. So any questions on the stack? I know I kind of rushed through the stack, but because the main topic is machine learning.
How is it used as APM?
Sorry?
APM, what's the use case?
Now we have also introduced APM agents. So we have agents for popular programming languages. So you can ship APM data, application performance monitoring data. You can connect your application using our APM agents. All the APM agents are open source. So imagine you have application logs, you have server metrics, you have APM data in a single data store, and you have a single dashboard where you can actually monitor all that data sets. It gives you the best insight into your application. So you can actually run machine learning jobs on top of APM.
Both of us have to remove it. Itna garam mat kar.
So you can run machine learning jobs on top of your APM data as well. So what is the response time for a particular API? You don't know what is the ideal response time. Maybe during peak hours the response time is higher. Say.
I want to request Ravi. Keep all the questions later. We
Sure.
are really under the clock.
Okay.
Yeah. Because we still have 3 hours of coding. I mean, so you can ask as important. And actually, those questions when you code will come even more relevant. And that is the one that's missing. Okay.
Okay. So I am assuming that you have a basic knowledge of Elastic Stack. I'll quickly jump to machine learning. Now it's machine learning. I know it's AI Bootcamp, but you'll say machine learning, AI.
Okay, here's a quick question. What is the difference between ML and AI?
ML is
Actually,
part of
Yeah?
ML is part of
Okay. That's so great. ये तो अभी composition हो गया, ये inheritance हो गया.
see, it's kind of you can have hours and hours of debate on what is AI, what is ML. I mean, I have a couple of small GIFs. They are disabled, right? This is the ideal artificial intelligence, and this is kind of machine learning. So there is a robot trying to open the door and going out, and this is a machine which just identifies the object and kind of the shape of the object and segregates them based on the shape.
So by the very definition, I mean, people who don't have learning can still be smart and intelligent. So you don't give data to machine learning, it can't learn, but AI, there are other approaches.
Yes.
I think so. If it's written in Python, it most probably is machine learning. If it's done in PowerPoint, it's most likely AI.
I have some big backup slides as well. I mean, there was an interesting tweet that when you are going for a funding, if you're a startup, you say that we are an AI startup. When you start implementing, it's machine learning, and when you actually go to production, it's actually some algorithm.
It's
not
Tally.
Recently something came out, right? A robot which won quite a few awards, and they found out that it's actually a human sitting behind that robot. So, I read that article yesterday. So yeah. So quickly jumping on to machine learning, I mean, very basic broad categories. You have supervised machine learning, you have unsupervised, you have reinforcement. I mean, I won't go into detail. I'll stick to unsupervised because that's what is available with Elasticsearch. So Elasticsearch provides unsupervised machine learning. It basically provides anomaly detection. What is anomaly detection? It's discovery of what's weird or different or not, or what is different from a particular set. And what is unsupervised learning? Learning without human labeled examples. You basically don't have to go and say that this learning is correct or this is wrong, or you don't have to give different data sets based on, you don't have to do anything. It's basically everything is unsupervised. And then you have Bayesian as well, which works on probability. So I'll quickly run through example. This is a simple chart. This is the airline on-time performance. These are different airlines at a particular airport. What do you think is there something abnormal in this?
Outline.
There's some outlier, right? Do you think there is something abnormal here?
Exceptional performance.
Hmm?
Same kind of.
Yeah. But is there something abnormal here?
Yes.
Okay. How about here?
No.
Depends if you are going with the flow, then
Exactly, it depends, right? It depends what you're looking at. And even here, it depends what you're looking at. Even here, it depends what you're looking at. And who defines what, how it depends, right? Everyone has to figure out. So if you have, example, if you have petabytes of data available with you, you have charts available with you, how will you define what is normal, what is abnormal? You have months and years of data. You give it to a data scientist, he may run queries, but how will he or she determine what is abnormal, what is normal? So what is normal? something behaves in a consistent way with respect to itself over time, or something behaves in a consistent way compared to against similar entities. So one aspect would be these are different airlines. There's a spike for a particular airline, but it's pretty normal. Or if it's a dip in that airline, this is normal to if you compare to data with data of other airlines, but it's not normal for this particular airline because usually the data is pretty high, but for this particular timestamp the data is pretty low. So this could be normal if you compare with other airlines, but if you consider only data related to that airline, it's abnormal. So normalcy could be with respect to itself or with respect to data corresponding to other data sets sampled at the same timestamp. This is just single data set. You see there is some abnormal behavior happening at this set of time, but that's the anomaly. And in this scenario, you're comparing data from different data sets or different airlines. This is normal, this is not normal. This is an anomaly. But even this part is somewhat anomalous. This is again an outlier, but it is still kind of related to the other airlines' normal behavior. In summary, if we want to define what is an anomaly, it is when an entity's behavior changes significantly and suddenly, and when an entity is drastically different than others in the population. So again an example, you have sea of penguins and you have a seal lying in between. Now why machine learning is needed for such kind of scenarios? You have data, say for example we were talking about, let's consider APM data. You have 100 APIs deployed in production. You have different response times for different APIs at different set of times. You have peak hours from 5 to 7 p.m. In the evening where the API response time is say 800 milliseconds, but at midnight the traffic is very low. From midnight to 6 a.m. the response time might be 200, 300 milliseconds. So that is the normal behavior of each API. So that could be the API response time. Now you want to get alerted when the response times are pretty high. What will you define as your threshold? There is no way to define a threshold, right? If you define threshold as 1 second, but at midnight the response time is 1 second, then that's not a normal behavior for an API. So that's why something like a machine learning is needed, which will detect what is the normal behavior for a particular data set or a metric, sample it against time and determine or find out whether at particular set of time whether the behavior is normal or abnormal or whether it's an anomaly. So that's the power of machine learning, and it's not that it is being claimed that it can do, it actually does. We have customers who are using this kind of machine learning jobs to monitor their entire IT ecosystem, to monitor their security threats and different KPIs. So that's pretty much possible, and it's being used in production. Now on learning, how will machine learn that it's normal? Very small example. I mean, it's kind of may not be very relevant in our case. I'm sorry, but how could I learn how much post mail that I get? We still get electricity bills. We still get bank statements. We still get some
Christmas cards.
Mobile visuals.
So, how can we determine that? So you can stand in front of your post box. You can watch how much mail delivery is happening, but for how long? 1 day, 1 week, 1 month? And you'll start getting some idea how much mail do you get daily, or in a week, or in a month, or in a month. And can we create a model using that data? Let's find out. So, at the end, machine learning is generating models out of the data sets that you have. So what is the probability that I'll get 1 mail a day, or 3 mails a day, or 4 mails a day, or I'm very important, I'm a government employee, I'm supposed to get hundreds of mails per day. How do you find out? You have different models to do it. You have probability distribution function, which can generate what is the probability of a particular data set to occur for a particular group or particular user or particular entity. So here we have the number of pieces of mail per day, and you have the likelihood or the probability for that. So now you may get there are 3 different entities here being mapped, 3 different coefficients or lambdas that are there. Someone has a probability of 1, that is 1 mail per day. Someone has 4, 10. It's for different type of users. No one single user may not have same number of mails they expect. So let's see. This could be your case that you expect 3 to 4 mails per day. It's could be a normal individual. But if it's a college student, they don't have their names registered anywhere. They don't have their names registered with utility, electricity bills or telephone bills. Even the bank statements usually go to their parents' name. So they might hardly get any mails. So this could be a college student where they are expecting hardly 1-2 mails a day. How many times did they get 5 mails a day? Very unlikely. Most likely they got only 0 or 1 mails per day. But if you look at this, it's a typical bell curve. It's a normal or an average individual. You have a bell curve. Bell curve is created for a lot of data. It could be for your appraisal. It could be for different things. But bell curve is the most standard distribution function that is available. But if you have a very old person who is subscribed to a lot of mailers, a lot of magazines, who has a lot of free time, they'll have a different function coming in. They'll have lambda equal to 10. They on an average expect 10 mails a day. So it all depends whom you are sampling. Now if you want to do such analysis manually, how will you do it? Will you create start creating such graphs yourself and trying to figure out what is the normal behavior of each entity? No, right? It's very difficult. It's doable, but it's very difficult. You'll need an army of people to run these analysis. That's why these are, you can say, low-hanging fruits for machine learning to solve. That's where machine learning can be really successful. Because there's a lot of data, a lot of different sets of data with different sets of behavior, and you want to understand their behavior, how they perform across various samples of time, then machine learning is a very good candidate to solve this kind of a problem. So if you start learning yourself, if you start analyzing that data, you may see data for a college student and you then determine that someone getting 10 mails is not a normal behavior, and you say there is a problem because you are looking into limited data sets for limited time. Okay, now how do we relate it to IT or security data, and what can machine learning solve? What are real life use cases which machine learning can solve and help organizations, customers, or you to better manage your IT ecosystem or better manage your business? Could be if you're looking at security analytics, if you want to see for a particular user what are the number of failed logins. So someone may have butterfingers. They usually keep on making mistakes while typing in their passwords. 2 failed attempts a day is pretty normal for them. But 5, it could be an anomaly, or 10 could be an anomaly. But someone usually types data pretty well, and you see for a particular day they have a lot of failed login attempts. Is it that someone is using that password? So it could be an anomaly. It's better to check. There's no way to figure these things out if you're trying to run queries on top of data directly. So machine learning can detect such kind of anomalies. Number of errors in a log. If you have an application log, you have errors happening. You get false alerts. They are pretty common. If you monitor your production data, false alerts are pretty common. You have 100 errors per day, but suddenly you have 0 errors a day for a particular application. Even that is an anomaly. Whether the application is even accepting requests or not, that could be an anomaly as well. Or you have 1,000 errors a day, that's an anomaly. It can bring down your system as well. 100 errors may be a normal behavior, but 1,000 is not. Calling APIs, you have a lot of fire1 errors or invalid credentials error. Someone is trying to hack into a system. Instead of they're bringing down their system, or they are able to enter into brute force, you are alerted beforehand that the number of incorrect attempts are pretty high. It could be an issue. There could be a rogue IP which is trying to log into a system. So that can be detected through machine learning as well. Or metrics. I spoke about response time. You have APM response time. It could be a CPU utilization. It could be a memory utilization. It could be disk utilization. You see data that the disk utilization is steadily increasing. So you can even do a forecast saying that my disk may get full 5 days from now because it's steadily increasing. So that kind of insights you can also gather from machine learning. Some business analytics, orders per minute. E-commerce website, generally you have thousands of orders coming through every day, but again based on time, 12 to 6 could be a lull period, but evening 5 to 8 could be a peak period, and you see there is an abnormal behavior in those periods. Either one of your end nodes is down, or the site is slow, or something is wrong with your ecosystem, the number of orders have decreased. So anomaly could be a decrease in the number of orders, or there could be a huge number of orders coming in. It could be a fraud scenario as well. So those are some of the metrics that can be captured and that can be monitored through the machine learning module in Elasticsearch. And we talked about this, right? What kind of model do you pick if you want to do it? This is the normal or the bell curve I mentioned, which is used pretty extensively, but not everyone conforms to this normal distribution model, right? There are various parameters in which can affect this distribution model. So usually people, even for evaluating people, they used to use a bell curve, but a lot of different studies said that you cannot actually put people in bell curve because there are various parameters, right? So that was the traditional way of doing it, traditional way of analyzing data. But if you involve machine learning, you can actually build, machine learning can build each model for each data set and figure out what is the normal behavior for that metric or data set.
You have 10 minutes.
Okay. So machine learning can pick which model is best suited for your data. It will study your data. It will figure out which is the best model for your data. Better models is better outlier detection and less false alarms. Anomalies occur when observation is in low probability area. So even in case of low probability, you can have anomalies as well. So I mean, it is more into details of what machine learning can do. I'll quickly run through what's possible with Elasticsearch. So this is an actual screenshot of machine learning anomaly detection in Elasticsearch, wherein this is a data set or a metric it is monitoring. And if you see first few cycles, it's trying to understand what is the normal behavior. So if you see the shaded region, it's trying to understand what is the normal behavior. It is sampled over time, so that it's a proper sine curve, you can say. It's an up and down based on what is the timestamp, what is the normal behavior. And it was trying to figure out what is the normal behavior, but as more data started coming in, it started creating a better model or a better typical behavior. If you see, the shaded region has gone really down. It's actually mimicking the actual values. So this is actual screenshot of Elasticsearch machine learning anomaly detection. So after 2 full days, it understood what is the daily behavior, and then after 2 full weeks, it understood what's the weekly behavior. So you have weekends coming in. So there's a dip in the transactions, or dip in the number of transactions over the weekend. So what does Elastic's machine learning do? It's online unsupervised learning. It does everything in real time. It also helps in auto-visualizing of your data. It does anomaly detection and it does forecasting. Inside anomaly detection, what is possible? Single or multi-metric. You can combine multiple data sets as well and determine what is behavior in relation with each other. It determines what is the outlier in a population, and it even figures out what are the rare events. So some rare process running on the server, it can determine it usually doesn't run on the server. It could be an anomaly. So some use cases you can solve with this machine learning: operational analytics, drop in number of orders, unusual traffic, early hints before things go wrong. In case of security analytics, man-in-the-middle attacks, malware, insider threat, maliciously running processes, sudden increase in network traffic, or suddenly one of the known outlier or blacklisted IPs get access, or they try to enter into the network. Business analytics, latency in response time, low click-through rates on ads, those things can be monitored, and you can try to figure out whether anything is wrong in your entire ecosystem. This is again a screenshot. This is high clicks per IP address. So for example, you run a blog and you want to monitor how many clicks are happening on your blog per IP address. It's impossible for you to figure out what is a typical behavior. Someone might be trying to scam you, or there could be some wrong referrals happening. You can actually monitor that data and will try to determine whether it's an anomaly. So even in the anomaly explorer, you can figure out what is the actual and what is the typical, and whether it's higher or lower, how much higher or lower is it compared to the typical behavior. This is the same metric here. You can sample data based on the timestamp as well. You can change the sampling time area. This is another new feature that has been introduced, which is you can create auto visualizations from data sets. You don't have to figure out what is the typical chart or what kind of chart should you use for a data set. Machine learning tries to figure out what kind of relationship between the data, different data points in a data set are, and it will try to auto create that chart. This is how you spin up Elasticstack in Azure. There is Elasticstack available on the Azure marketplace. It's available for on-prem as well. On Azure marketplace, you can just quick search on Elasticsearch or Elastic. You can find the official distribution of Elasticsearch. When you're done with setup, you have the Kibana visualization. It's pretty easy to start inserting data into Elasticsearch. You can insert various types of data sets. It's pretty flexible. So even ingesting data into Elasticsearch is pretty easy. And once data is there in Elasticsearch, you can start playing around, start building machine learning models on top of it. I quickly ran through it. I know we are running short of time. Any questions so far?
Any questions? No?
Okay, I'll show a quick demo. Just give me 1 second.
So in the meantime, are you guys playing the racing car game?
Yep.
Driverless, built on ML, AI?
Yes.
And we are second. China is still first. क्या कर रहे हो भाई? खेलो इंडिया खेलो. Huh? हमने got the game. अरे योगेन तू तो गेम तो खेल. और सो मत जा उस पे. गाड़ी किसको टोकेगा?
So I'll quickly run you through the machine learning UI. Then maybe we can stop and then take up questions if any. So there's no coding involved. As I mentioned, it's unsupervised machine learning. You basically have to insert those data sets. You can then create jobs on top of those data sets. We call it metrics. They are sampled against time, usually time series data that we look into. So it could be a CPU utilization per second, per minute. It could be high click rate or the click rate. What's the highest click rate per minute? Could be in case of business analytics, you can have say e-commerce website. What is the abandon rate of your cart? People usually add items to their cart, but they don't go ahead and buy them. But what is the typical ratio of that? It depends on which type of e-commerce company it is. They may have say 70 or 80% abandon rate, but suddenly you see a spike in high abandon rate. There could be a problem where maybe a few of the checkout pages may be slow. How do you determine that? It's nearly impossible to determine. So you want to monitor the abandon rates as well. What is the threshold for abandon rates? Again, you cannot define those thresholds. So if you want machine learning to learn what is a typical abandon rate over time and figure out whether there is an anomaly in high abandon rate, you can even create jobs on top of it. What is your site performance? What is the 95th percentile performance? What is the 99th percentile performance of your website? You have APM data coming into Elasticsearch and you want to run machine learning jobs on top of it. You can try to figure out what is the normal behavior of your website at what time, what set of time. So there are a few jobs which are already created. If you want to see what is your performance? There's a single metric viewer available. It has it charts the metric over time, and you can increase or decrease the sample rates as well. This is daily sample rate. You can see there is an anomaly. Anomalies are detected. If you click on that anomaly, it will even say that what is a typical. It's 1,470 milliseconds is a typical performance, and suddenly it has become 1,700, which is 1.2x higher. So it detected that it's not a typical behavior, it's an anomaly. You can even go to Anomaly Explorer and see how many anomalies happened over time. All that data also gets stored into Elasticsearch, so if you want to run visualizations on top of anomalies, you can do that as well. So
फोटो लिया ले ले भाई, ये भी स्पीकर है।
आपको सबका मेल आया?
सबका मिला है? मैंने देखा नहीं। अरे अभी सक्सेना भी आ गया। अभी सक्सेना कौन है भाई? तो ऋषि जगताप कौन है? अरे सिर्फ मैं में सिर्फ 3 आया बस।
Anyway, this is the Anomaly Explorer. You can look at the anomalies that have happened. If it's a false positive, possibly if the data is pretty low, the data sets are pretty low, you can have false positives, but it usually takes 3 complete cycles to understand what is the typical behavior. After 3 cycles, it starts creating the normal behavior more accurately. So initial few cycles you may see some false positives, but as and when more data starts coming in, it kind of fine-tunes the model and fine-tunes, figures out what is the typical behavior. So that's a small demo on this. So any questions so far?
Any questions? Yeah, go ahead.
So when we talk about anomalies, that's how it's used even when you do diagnostics. Say, use deep learning for diagnosing a cancer. They figure normal and find anomalies. So anomaly detection would be a feature across all kinds of
data. So, but see, in case of cancer, you have different samples. You have medical samples available. So if you can put in that data into Elasticsearch
and define it as a normal, and anything out of that is an anomaly.
Right now it works on time series data. So if you have sampled data against time, it detects what is the normal behavior across time.
Right.
So if you have what is the cholesterol level or what is the WBC or RBC count.
No, even if you log into Gmail from from a location which is not normal, it might be detecting an anomaly and asking you.
So what Gmail typically does is it kind of whitelists certain IPs. When you log in for the first time, it will say, shall I whitelist? So it has something to compare. But if you have an e-commerce website that you're running in, you don't know what is a normal IP address, right? You cannot whitelist or blacklist IP addresses. But you see there's a huge traffic coming in from a particular IP. That could be an anomaly. You have thousands of hits coming in from a single IP per second. That is an anomaly. So what could be that IP? It could be from North Korea. So you can't keep the list of North Korean IPs as blacklist, but you might also have certain customers from North Korea as well. Never know.
You never know.
Huh?
Never know.
एक ही कस्टमर है उधर, किम जोंग इल।
Yeah.
So apart from this AI and ML part, how code intensive is your platform?
Yes.
How code intensive, and how much effort is it needed to develop one? Suppose I want to develop an Elasticsearch for suppose Alexa. I ask these types of questions, so it should know. So
It's not at all. I can show you.
your development platform is based on
It's
SDK.
It's not a SDK or anything. You have Elasticsearch. It's a NoSQL data store. REST APIs are available. You can start inserting data into it. Then for querying data, for running searches on top of it, you again have REST APIs available.
Okay, so we just have to use those REST APIs.
You have Java, Python clients also available, but REST API is a standard. For inserting metrics data, for inserting logs data, we have ready modules available.
Okay.
Logstash is for log data. Beach has multiple modules. It's again open source. Everything is open source. So there are a lot of community-driven modules. So you have connectors for more than 200 data sources available. For example, Elasticsearch is now becoming a very popular big data solution as well, a real-time big data solution as well, because it's highly scalable. So one of the popular modules is ES Hadoop. So Elasticsearch Hadoop. So what happens is people who created Hadoop ecosystems, they want to run real-time analytics on top of it. So what they do is they fetch data from Hadoop, insert into Elasticsearch, run their real-time analytics, and then publish results and even put it back into Hadoop ecosystem.
Actually, that's also closer. The guy who created Hadoop. Elasticsearch.
So Elasticsearch is actually based on Lucene.
Yeah.
So Lucene and Hadoop.
And Solar is also there.
Yeah.
Solar is. Both are based on the same, but the way they do it is slightly different.
So Solar and Elasticsearch, I mean, they kind of started nearly at the same time. Lucene is a Java library for search, and Solar, Elasticsearch, both are based on Lucene. So Elasticsearch, when it started, Shai Bannon was the author of Elasticsearch, chose it that he thought it is better to make it horizontally scalable. But Solar guys, at that time, vertical scalability, because the original relational databases, we keep on adding hard disk,
RAM.
keep on adding RAM and CPU to the same server. That's how they used to scale, and Solar chose that way. So in a way, that's why Elasticsearch became more popular than Solar, because it chose to be horizontally scalable, and now it has becoming
And cloud.
The cloud, it's kind of cloud native.
They have to-
So
Cool.
everything is container based as well. So in fact, we have our own cloud platform available as well. We are going on Azure in some time.
Yeah.
Azure as an option for a cloud platform. Internally, it uses containers for
Docker. I'm somehow all connected with all of them. Okay. I will try. Just request you to keep your questions now, because we need to start the MR,
Okay.
because that's following up. So we'll move you guys to the cafeteria. He will be showing you any what he wants to demo or anything like that.
I'll talk to you.
Okay, cool. So I'll bring this to close. Huh?